Next, we introduce the logarithmic notation and its properties. Recall the exponential notation which we use to denote the product of n b's. Just like there is an operation of subtraction to undo addition and an operation of division to undo multiplication, there is also a way to undo exponentiation. As a matter of the fact, there are two ways. We call nth root of a number a the number that is when raised to the nth power is equal to a, and we use the radical notation to denote the nth root. Similarly, we call the logarithm of a number a with base b the power that b needs to be raised to get the number a, and we use the logarithmic notation to denote such number. So, if we know that 2 to the power 3 is 8, we automatically know that the cube root of 8 is 2, and the logarithm of 8 with base 2 is 3. Similarly, if we know that the fourth root of 81 is 4, we automatically know that 3 raised to the fourth power is 81, and the logarithm of 81 with base 3 is 4. Finally, if we know that the logarithm of 125 with base 5 is 3, then we automatically know that 5 raised to the third power is 125, and the cube root of 125 is 5. Similar to how subtraction is learned by undoing addition and division is learned by undoing multiplication, we learn radicals and logarithms by undoing exponentiation. We can take the exponentiation table and turn it into the table of radicals by simply understanding the radical notation. It is strongly recommended for you to be familiar with all radicals in this table and understand how other radical statements can be made in a similar way. Similarly, we can take the same exponentiation table and turn it into the table of logarithms by simply understanding the logarithmic notation. It is strongly recommended for you to be familiar with all logarithms in this table and understand how other logarithmic statements can be made in a similar way. Many properties of exponents can be converted into properties of logarithms. We call the logarithms with base 10 common logarithms and omit the base when writing out the statement. And we call the logarithms with base e natural logarithms and abbreviate it with ln. One nice thing about logarithms is that you only need to know logarithms with one base, and all other logarithms can be related to it using the change of base formula. Frequently we use logarithms with base 10, thus the name, common logs. However, in many applications it will be helpful to convert to logarithms with base e. For example, the logarithm of 64 with base 16 can be converted to base 2 to obtain the answer 3/2, meaning that 16 raised to the power 3/2 is equal to 64. Using the properties of logarithms, we can either expand or condense a logarithmic expression. Here's an example of expanding one. And here's one for condensing. We introduced the logarithmic notation and its properties, and how to use the properties to expand or condense logarithmic expressions.